In this video, I'm going to show some examples of how to solve by factoring. The first thing you need to know about solving by factoring is that you need to use what's called the zero product theorem. Zero product theorem says if you have two things and you're multiplying them together, and this could actually apply to three or more things too, and this equals 0, then either A is equal to 0 or B is equal to 0 or both of them are equal to 0. Okay, that's the only way that you can multiply to get 0. So this term has to be 0, this term has to be 0, or both of them could be 0 at the same time. So that's the idea that we're going to work with. One thing to keep in mind, there is a multiplication symbol here. So 0 times a number is 0, but if you add 0 to something, that doesn't work. Okay? Doesn't always work is what I should say. So what I want to look to do is see, first of all, okay, I know my equation is equal to 0. Good. I like that. Now I want to look at the other side of my equation and see, is this in a multiplication format already? And it is. So right here is where I would have some multiplication. So what I'm going to do is take each part of the multiplication. They're called factors. I'm going to take each factor and set it equal to 0. If I need to do any kind of solving, that's what I'm going to do next. So this particular problem is already done. It already says x equals 0. The other little equation here, I'm going to add 6 to both sides, and I'm going to be able to say that x is also equal to 6. So I have two answers. For a lot of these problems, you're going to get two answers, so be aware of that. All right, this is what happens if a problem is already factored and it's equal to 0. I'm going to slide on over to problem 2, example 2 here. So things I look for, is it equal to 0? Yes. Is this in factored form? Yes. How do I know it's in factored form? Because it's written as a multiplication problem, right? Parentheses next to each other mean to multiply. And so that's what I'm looking for here. I'm going to take each factor, set it equal to 0, and then I am going to solve. So normal rules for solving. To undo addition, I'm going to subtract from both sides. To undo multiplication, I'm going to divide. And I do not need you to grab a calculator. Just leave this as -8 over 3. That is a completely valid answer. It's the exact answer. It's good. For the other equation here, I'm going to add 7 both sides. So n is equal to 7, and that is my other solution. Okay, so again, the nice part about this particular example is you already had it factored. You already had it equal to 0. Okay. All right. Example number 3. Is it equal to 0? Yes, it is. Is this factored? No, it's not. So we need to factor this. Quick reminder, you are looking to multiply to 30 and add to 11. So looking for two numbers that multiply to 30 and add up to 11, plus 6 and plus 5. Quick double check. 6 times 5 is 30. 6 plus 5 is 11, so I know I have the right two factors. And now that I've got the factors, I'm going to split it at the multiplication. Take each factor equal to 0. And now I'm going to solve for the variable p. So subtract 6 from both sides. P is equal to -6. Subtract -5, or subtract 5, sorry, these are the right terms. P is equal to -5. So two answers here. All right, and yes, you need to make sure that you identify both answers when you are solving these problems. Okay, example number 4. Is it equal to 0? Yes. Is it factored? Unfortunately, no. So that's what we're going to factor. We're looking to multiply to 24 and add up to 10. So I need to be careful with my signs here. I'm going to split my k here. What multiplies to 24 and adds up to negative 10? Negative 6 and negative 4. Negative 6 times negative 4 is positive 24. Negative 6 minus 4 is negative 10. Take each factor, set it equal to 0, and solve. So k is equal to 6, and k is equal to 4. All right, so you've seen examples now where you had problems that were already factored. In this case, you had to factor. So you can see both of them, and it just depends on what what kind of problems you have here. All right, problem number 5. Is it set equal to 0? Yes. Is it factored? No. So a factoring we shall go. All right. This is a particular type of problem because you have a number other than 1 in front of your x squared. Okay, so this number right here, you either need to do a little guess and check, right, or you need to use the AC method to solve this, or to factor this. It's really up to you. I'm going to go ahead and do guess and check for this one. The only way I can get a 2 is 2 times 1, and the only way I can get a 5 is a 1 times 5. So there's not that many options here. So 2x and x, and let's go with a negative 5 and a positive 1. I'm going to do a quick check on this. So my quick check here, if I do negative 5x, and if I take these outer terms, that would be plus 2x. Yep, that gets me the middle term I'm looking for. Now, normally I'd leave that and just show my extra work, but because I need to actually go further, I need to split this at the multiplication and set each factor equal to 0. Once they're equal to 0, solve them up. So add 5. So 2x is equal to 5. Divide both sides by 2. Fractional answers are absolutely okay. In fact, my preference is to leave them as fractional answers. So 5 over 2 is one value for x. And if I solve my other little equation here, I will get x is equal to negative 1. Please make sure, again, that if you find both of, you're looking for both of your answers, okay? All right, example number 6. For this example, I'll go ahead and use the AC method to remind you what that is and how it looks. So we've got A, we've got C. Looking for two numbers that multiply to negative 20 and add up to positive 8. So if I take 10 times negative 2, that will multiply correctly and add correctly. Okay. So leave your first term alone. Split your middle term using the two values you just found. Okay, so there's a split. Group the first two. Look for a GCF. Group the second two. In this case, they're both negative, so I'm going to plot a negative. And write down what's left over. Okay. Quick check, those two parentheses sets are in fact identical. So that becomes the next GCF I'm going to take out of the whole problem, leaving behind 5n minus 2. So you've now factored your problem. Now is the time where you're going to set each factor equal to 0. Do a little solving here. So n equals negative 2. Do a little solving here. So 5n equals 2 divided by 5. N is equal to 2/5. Leave it in decimal form, please, unless the directions say otherwise, and the directions would explicitly state decimal answer or approximation. All right, so that is what happens if you have to factor when it's equal to 0. But let's take a look at two more quick examples here. Problem number 7, example number 7, very first question I always ask myself is it equal to 0? And immediately, that's not 0. So I need to figure out what I can do to make that negative 2 become 0. So I'm going to add 2 to both sides. So that's going to turn into m squared plus 8m plus 7 is equal to 0. Now that it's equal to 0, factor it. So looking for two things that multiply to 7 and add up to 8. So plus 1 plus 7. Set each factor equal to 0. So m is equal to negative 1, m is equal to negative 7. So you have to make sure that these problems are equal to 0 before you try and factor them and before you try and set them equal to 0. So make sure it's equal to 0, make sure it's in factored form, then set each factor equal to 0 so you can solve. All right, last example, problem number 8. Same basic idea. This is not 0, so I want to make it be 0. So I'm going to add 10, and I'm going to add 10. Now, the right side's the easy one. That's the 0. The left side, what I need you to be careful about is these three terms, none of them are like. So n squared plus 7n plus 10, just write them down in descending order. Just means you started with the highest power and dropped down. And now factor. So split the n, what multiplies to 10 and adds up to 7. That's positive 5 and positive 2. Take each factor now, set it equal to 0. Once you've got your two equations, solve them up. N is equal to negative 5, n is equal to negative 2. All right, so things you need to make sure you have. You have to make sure your equation's equal to 0, equal to 0. You have to make sure that the left side in this case is factored, so it's factored. Once it's factored, set each factor equal to 0 and solve those little equations. I hope these examples have helped. Let me know if you have any questions.